Hey guys, this is Einar. I hope you're doing great today, and welcome to this tutorial where we're going to be talking about how to create confidence intervals using the t-distributions. Now, the t-distribution is especially adapted for use in samples that are very small. Basically, one guideline is that if you have a sample that is smaller than 30, you should actually be using the t-distribution for confidence interval rather than the normal distribution, which we used in the last tutorial. So to begin with, we're going to count the number of observations we have in our data set, like that. And we find that we have 12 observations. Well, okay, that's a signal. We should be using the t-distribution. And why is that? Well, when we have very small samples, we have more uncertainty in our guesses, and that's very intuitive. If I asked a lot of people, like 1,000 people, I would be sure of my guess of, for example, the average, than I would if I had only asked 12 people. The more people you ask, the more observations you have, the surer you can be. And we have to take this into account. So the confidence interval for the t-distribution is based on the t-distribution curve, which is sort of like a normal distribution. Has a lot of the same characteristics, but it's sort of like if you had a normal distribution like this and you pushed it down and flattened it out, you have more probabilities out here in the tails, which will give her broader intervals to take this increased uncertainty into account. When it comes to other aspects, it pretty much looks the same. We have pretty much the same formula for the confidence intervals, except, well, we're using t-values here because we're using a different theoretical probability distribution. But as before, we're going to need our average, which is the center point of our interval. We're going to need the standard deviation and the square root of our n in order to be calculating this standard error, which is a part of the formula for the confidence interval. We will also be calculating the degrees of freedom, but I'll talk more about that in a second. For now, we're just going to begin by calculating the average. So I'll write equal to average. Select my data. And I find that in my data set, our Tango dancers have on average 204 friends on Facebook. The standard deviation around this average, well, I select my data, I find it is 159 Facebook friends. So that's all we need for the calculation of the standard error, which is the standard deviation divided by the square root of n. So let's calculate that. I select my standard deviation, so this part of the formula, divided by the square root of n, which is right there, like so. Okay, so we get a standard error of 45.93. And you might think, okay, we now have everything for our confidence interval formula, because the t-values, just like with the normal distribution, we could look that up in tables. Well, kind of that's almost true. The thing is that because the t-distribution is adapted for small samples, it will change its appearance and become more and more normal as our sample size increases. So that's why we have to find our degrees of freedom, so we know what t-distribution we are actually looking at. There are several t-distributions, so I will write equal to 12 minus 1, which are the degrees of freedom that we have. Now, I've already found the critical t-values for us, but I'm going to show you really quick at the end of the tutorial how to find the critical t-values. So if you're just interested in that, you can go to the end of this tutorial and you find that. But we're going to start calculating because I have the critical t-values here. So the centermost point of my data is x bar, which is 204. So I select that, and we have 204 here in the middle of our confidence interval. So that's that part of the formula. For our lower limit, I write equal to. I select my x bar there, and because we're working with the lower limit, I'm going to need to use my subtraction sign there, subtracting our critical t-value multiplied by a standard error. And I get 103 as my lower limit in my confidence interval. Now for my upper limit, I select my x bar. And because I'm working with the upper limit, I'm going to add, so it's plus here, my critical t-value multiplied by my standard error, which is right there. So I get an upper limit of 306, and the range between my upper limit there minus my lower limit is 202 Facebook friends. So it's a pretty broad confidence interval, you might say. So it's pretty brutal in that way, but at least it's something. It's a confidence interval. And what we're saying at 95% confidence level, well, that is a confidence interval that covers 95% of our distribution, and translated to a confidence interval, that means that we have our center point of 204 Facebook friends, a lower limit of 103 Facebook friends and an upper limit of 306. And what this means is that if I conducted my sample 100 times, in 95 of these times I will get an average in my sample that is in between these critical points. And that also means that in 2.5% of my samples that I have conducted 100 times, I will get an average that is below 103, and in 2.5% of those samples I will have an average that is above 306. So basically it's very similar to the confidence interval for a normal distribution, with the important difference being that it's using the t-distribution. And now I'm going to be showing you how to find the critical t-value for a certain level of degrees of freedom. So we have 11 here, and I'm going to be using a t-distribution calculator, which I found online here. What I have to write here first is, this is the difference compared to before. I have to write that I have 11 degrees of freedom. And in this part here, the probability, the cumulative probability for values below 2 or equal to my critical t points, so to speak. And that means that how many percent is below my critical t value. And in this case, it's going to be 0.025 because I have a 95% confidence interval. I calculate that, and I get a critical t-score of minus 2.201. I'll find that, okay, so my critical value is 2.20. 2.201, yeah, it's been rounded off. If I have a 90% confidence interval, I'll choose 5% instead. Oh, right, I have to delete this before. Delete that. I get a critical t-score of minus 1.7. I'll find that, yes, I've wrote that in here before, but it's been rounded off. So that's why it's 1.8 there. So it's been rounded off. I'll calculate this for you guys. If you feel safe, you can just quit the tutorial for now. But if you want to practice, you can do this along with me. We find our center point, which is 204. I write equal to here. I choose my average minus my critical t-value, which I found with my distribution calculator online, multiplied by the standard error, and get a lower limit of 122. Now for the upper limit, well, I select my average right before, plus my critical t-value, multiplied by the standard error. And I get a confidence interval, which is actually smaller than the one I had for my 95% confidence level. And that's because I've been decreasing the amount of probability that is located in between my critical values. And you might say, well, that's better, I have a smaller interval. Well, I say, okay, fine, maybe, but that also means that I have a lower confidence level. So in this case, I can only say that my average will be located in between these two critical values in 90 out of 100 cases if I conducted my sample 100 times. So bear that in mind when you're choosing your confidence level. So that's it for this tutorial. I hope you have some fun playing around with these numbers. Try to change them and see how that will have an effect on our confidence interval. But otherwise, I hope you have a really great day. Bye bye, guys.